see the slides. So today I'm going to be talking about creating Debian embedded systems using a tool called Debos. This is a continuation of the talk I gave last year at the Embedded Live conference, or the Live Embedded event. Hopefully we've got some more information to share with you all over the last year of things that have changed and been updated. I've left my contact details on the screen here. If there's any questions or queries you have after, please do get in touch, email or Twitter or whatever. You can hopefully see me there. I've also been informed there's a Slack channel, track 2, I think, that you can ask questions in during and after the presentation. So a little bit about me. I'm an engineer at Collabora. I'm originally an electronics engineer by trade and training. So hopefully I have a little bit of experience based on embedded systems from that kind of path, and hopefully that will help with explaining certain things that may not be apparent for just pure firmware engineers. So I'm working on custom distros for cloud embedded and PC devices. So these are things that run in, say, AWS or on little Raspberry Pi style embedded boards. Also, we work on x86 platforms as well. I'm also working on continuous integration and all that fun stuff around the distros, which has been quite interesting. I've also been working on packaging, mainly Debian packaging, and over-the-air upgrades using tools like Rauk, which there are other talks at this conference on. And a big part of my work is also on continuating the Debos tool and making sure that Debos still works really well. And hopefully we're going to learn a little bit about that today and what the stuff I've been working on. So a little bit of an overview of what we're going to talk about today. So as I say, this is kind of a part 2, but also just an update since what happened this time last year. And I cannot really understand what's gone so quick. The whole year has just gone really quickly. It's amazing how quickly it's gone. I see in the chat we've got some problems with the sound, which is not good. Some people say the sound's fine, others say it's not. Maybe that's at your end. I'm not entirely sure. So we're going to go through what Debos actually is, why you should use Debos compared to some other tools and that sort of thing. And I'm going to give some updates to what we've done in Debos since this time last year. I'm going to go through some example recipes, including a Raspberry Pi recipe, and also how to build some images in the cloud. So building images on GitHub as well as GitLab using the CI that's kind of in the cloud. So that's going to be hopefully a nice, interesting part for you. And then at the end, we're going to have a question and answer session. I'm going to go for about 20 minutes, and then hopefully the questions and answers will take up the rest of the time. So please, if you do have any questions as we go through, ask them in the chat and I'll come back to it at the end. There's also, as I say, a Slack channel. So please ask the questions there and I'll go through those right at the end as well. So, I mean, a lot of people these days use things like Builderroot and Yocto for their distributions and their kind of custom images for embedded devices. But personally, I think all of that is really kind of over the top for certain use cases. I've left some information on the screen about why Debian should be used as a base, in my opinion. I'm not going to go through all of these. You can read through those yourself and look at them in the slides after the presentation. But the main thing I'm going to say is using Debian allows you to concentrate on the application rather than all of the middleware and things like getting a shell and things like SSH servers and other packages like that. So you can build on the work that other people have done and quickly install new stuff, but you can then concentrate on your application and your bit of software that work on. You don't really want to be working on that middleware stuff. So I'm also going to go through why you should use DebOS. So there are lots of tools already out there to build Debian images, but we weren't happy with using those tools. I mean, there's a slide show with a link there in blue by Riku Vuipo, which summarizes all these other tools and their downfalls. I'm not going to go into that right now. You can click on these blue links if you download the slides after the presentation. I've heard they're going to be saved somewhere for you all to have a look at. But the main thing really here is all the other tools, they serve their own individual specific purposes, whereas DebOS really was designed to be very, very generic, and it can be used in lots of different situations. So Collabora, we're using DebOS for lots of our projects, including Apertis, which is a Debian derivative which is designed for use in the automotive space. And basically from that project, we're continuously upgrading and fixing DebOS and letting it do new things. So that's quite nice. Some other things about DebOS is it generates the image or your kind of output from a YAML file. Some tools, they have like a long command line with lots of arguments and things like that. So I think that DebOS can be used a lot more generically and nicer by other people. So because it's this one configuration file, that can be stored in version control as well, which gives you all the benefits of using something like Git to version control your distro. So what DebOS actually does is it uses a library called fake machine to create a virtual machine, currently in KVM or user mode Linux, which we'll come back onto in a minute. And then everything is done inside that virtual machine, so your host isn't affected. In some other tools, this is done by mounting images as loop devices, which is always very tricky. I mean, every system is kind of different in that respect. And then we have a recipe, which is a YAML file, which contains lots of actions, which are steps to create your image. I say image, you don't have to actually create an image. You could create kind of anything, a tarball, you could create all sorts of different intermediate stages, if you like. And then these actions abstract all of the commands and the changes that are actually done inside this virtual machine. So there are some actions which we're going to go into in a second, which are kind of basic ones that come with DebOS, but we're also always looking for new actions. So if there isn't an action, you can run a shell command or you can run a script, a bash script, and eventually that can be created into its own action if needed. And then the nicest thing I think about DebOS is if anything goes wrong or breaks, there's no impact to your host system as if there would be with some of the more traditional loop device methods. You can just kill the virtual machine. So that is very nice. And I think also this fact that it's done in a virtual machine means it's reproducible pretty much anywhere that can run this virtual machine. So who's using DebOS? So this is pretty much the same as last year. I mean, I've not heard of anyone new using DebOS, but again, if there are anyone here that's using DebOS who's not on this list and you want to be on the list, please get in touch and we'll add you to the list for next time. But basically the biggest customers or consumers are Apertis, which, as I've already mentioned, is a automotive Linux or sort of Debian derivative. Kernel CI, which is a Linux Foundation project, Redaxa, Mobian, Plasma Mobile, loads of mobile sort of projects are using it these days. And also reproducible builds have started using DebOS. And I think also Debian now are starting to use DebOS to generate Raspberry Pi images, which is all very nice. So I've said a lot about this already, but what actually is DebOS? So it's a tool that's written in Golang by Collabora, and it's split between DebOS itself and Fake Machine, which, as I said, is the library which handles creating the virtual machine. You can also use Fake Machine standalone, which I think is quite nice. You can have a fake machine and attach images to it and then work on those images either manually or in a script, which can be very handy. I use Fake Machine to actually modify things like Ubuntu images by mounting them and then getting a shell inside it. It saves you having to sort out any loop devices or any of that sort of stuff, which is, again, very nice. So you don't need to know Go to use DebOS. You may need to know a bit of Go to work or hack on DebOS, but it's very simple the way that Go's been used. I mean, I picked up Go in the space of a few weeks, really, to add patches to DebOS. So the packages are in Debian stable, so you can, excuse me, just having a drink. So you can run it on Debian stable. You can also run it on Debian unstable, of course. We've also got a Docker container, which should let you run it anywhere. And that Docker container, as we'll come on to later, just needs a few extra parameters. You can also install it from source on other operating systems. I mean, we've got some people using it on Arch Linux. I think it's also in the Arch user repository as well. I need to double check on that. So then the tool DebOS, it takes a recipe input on the command line. So you run DebOS and then you have your recipe.yaml, and then it loads up the recipe. And this YAML file contains all of the steps which are used to create your image or other output. As I've said, YAML is quite simple and it can be version controlled. I mean, if you've not seen any YAML, it's the same file format that things like Docker Compose uses, and a lot of other open source projects use YAML for kind of configuration and things like that. Just by looking at it, you can get started. So the DebOS recipe, I'm going to show you an example in a second, but it contains some metadata at the top. Currently, only the architecture of the image that you're generating, and then the actions, which are an array, which are then run sequentially. Each one of these actions has their own properties, variables, and things to do. You can put comments in there, of course, and it's pre-processed through a templating engine, kind of like an HTML page in a web sort of engine. So you can do things like, you can put some scripting in there, you can put variables in there, which you can pass from the command line. And you can also include recipes from other recipes, which helps you sort out things like components. We'll get onto these and what they look like next. So here's a quick example. I'm going to rattle through this very quickly. But as you can see, starting at the top, we've got a comment, and then we define the architecture. And then we've got an array of 4 actions which actually create the Debian system. So this actually creates a tarball of a very basic Debian system with the kernel. So as you can see, the first stage, there's debootstrap, which debootstraps a Debian testing system. If you're familiar with Debian, you'll know what debootstrap does. If not, it basically just installs all of the very basic packages that you need. So things like bash, all these other GNU commands, that sort of thing. You can choose a mirror where it pulls it from. So there's nothing that says you need to pull a Debian system. I mean, you can pull Ubuntu here just by changing the mirror to the Ubuntu mirror. You could build an Apertis system by changing it to the Apertis mirror. You could build your own system by pointing that to your own mirror. Then we install Linux image from the Debian repository for the AMD64 architecture. And then we run a command inside the system. So the chroot argument here actually defines that it is inside the system that we're debootstrapping. And then finally we pack it, and this pack actually ends up tarballing the system, and that's your output simple OS pack. So then, just get rid of that. So then this is how you'd run it on your system. So you'd install Docker, and then you run this Docker command here, which has got some other metadata. So you can see that we actually bind the KVM kernel device inside that machine, and then this lets you run or create kernel virtual machines. So this is actually using the KVM backend in DebOS, which we'll get onto. And then we mount the local directory. So this lets the output be stored on your machine rather than inside the Docker container. and then we just put the name of the recipe at the end. So here you can see the 4 actions all collide, and they're very similar to the recipe that we've just shown you. So here you can see the recipe on the left and the output on the right. So we've got the 4 actions: debootstrap, apt, run, and pack, and these are shown in the log here. Obviously, there's a big log that's outputted when you run these debootstrap and apt commands. I've removed that for clarity. And as you can see here, it takes, I think, 4 minutes or less to run. And you can even get quicker results if you have like an apt cacher or something like that running on your local system, where you can store everything in kind of a local copy. And then it doesn't even need to access the internet then to build your image. So the actions, I mean, I've been through what debootstrap does already, but again, you can debootstrap a basic system in that target file system from a mirror, and then these other parameters like suite, components, and variant. These are the same arguments you would have if you were to run debootstrap on the command line. It's just nicer in a kind of easy to read format, so you don't have any bash scripting or anything like that. It's very quite nice, the fact that it's in a YAML file, I think. And then again, the apt action actually pulls the apt packages that you suggest. Again, the same as running the apt command on the command line. It pulls in all of the dependencies, the package as well. So if you installed something like LibreOffice, it would pull in all of the kind of fonts that are needed and everything else. There's also recommends on here, which is an argument that is actually passed to apt. So you can install even more packages from that as well. Again, under the hood, it just calls apt to install everything and handles everything else the same as apt would. And then pack and unpack lets you pack and unpack tables. This is quite nice when you've got multiple recipes. So you may have a recipe that creates a very simple table, and then you may have a different recipe that turns that table into an image, for instance. You can run the first stage of your image, normally called an OS pack, and then tarball it up. And then in the next stage, you can unpack the tarball and then put it into an image. And then the most important one, in my opinion, is the image partition action. Anytime that I need to create an image these days, I'll just use this image partition action because it can create an image very quickly. You haven't got to worry around using tools like fdisk, parted, because this action abstracts all that information away and puts it under the hood. So in this example here, we're creating 2 partitions, an EFI boot partition and a root partition. And then we also mount that inside the virtual machine as well, so we can do work on it. You can only create currently 1 image per recipe, but this hasn't actually been a problem so far for us. I mean, this is how it works. So it works quite nicely, in my opinion. And then you've got file system deploy, which basically copies all of your files into that image you've just created. By default, the root file system is stored in memory and you have to manually copy it over. In cases where you may want to not actually put anything on your image, I mean, there's some cases where you may not want to copy your files to the image. So we just make this step separate. So you have to actually deploy your files to the system or the image. So overlay is, if you've ever worked with Docker, you'll know what overlay is. It just copies the files from your local system into the target file system. So you can copy things like configuration files or some software or something like that. And it preserves all the permissions of the original files. So that's, again, very quite nice just to copy some files in. I mean, the common case we use this for is copying in custom configuration into an image. So somewhere like /etc or something like that. So then the raw action is used to write images to the partition, or well, it's used to write images to the image, if that makes any sense. So you can use this to install bootloaders. So for instance, you can write U-boot to a certain offset of the partition or the image itself. The run action is kind of, in my opinion, another important one. It allows you to run commands or scripts with arguments inside either the virtual machine or inside the cheroot inside the virtual machine. So you can directly work on the image that you're creating, or you could also do some other things like run a post-process script which runs after the virtual machine shut down. So we use the post-process commands at the end of the recipe to do things like zip up the image or create BMap tools, do things like SHA sum the image, checksum the image, that sort of thing. So basically with the run commands, you can run any command that is on your PC inside the virtual machine or after the virtual machine shut down, or you can run any commands that have been installed inside the cheroot while the virtual machine and the cheroot are running. So this lets you do things like, if you remember my original example, it uses an echo command to write some data to a file. So then we get some more complicated action, recipe, which allows you to include recipes inside another recipe. So this lets you basically abstract things into another recipe. So you could have your main recipe and then a standalone recipe which installs something like, I don't know, LibreOffice with all of its components that goes along with it, sets up all of the configuration for that app, and it lets it just be abstracted in somewhere else that is just for that kind of component. You could also do other things in this recipe, like set up things for different architectures or that kind of stuff. It's basically your choice how you include recipes. Then the other important thing is the variables that you can add. So you can set variables inside the script using the format at the top where we set a variable. This has got a strange syntax. I mean, I really struggled with this at first, but basically it means that you can set the variable from the command line by passing the name of the variable and then a colon and then the value of the variable, much the same as how you would with Docker commands. But we also offer a default. So if you see here, we're only passing in 2 variables. So then this image variable will be the default that's here. And again, this is another strange syntax, but this allows you to create on the fly from the previous variables. So you can then pass these variables into the script and use these in different places. So here you can see I'm setting the architecture, the suite, and the output file name from the command line. And then scripting gets a little bit more interesting and more complicated because you can do things like change different parts of the script based on the variable contents. So again, we're setting the variable here, and then we're running, or we're passing these parameters to the packages that are installed based on the architecture. So I mean, with the if-else statements and things like recipes and variables, everything can really come together to make a really complicated and nice system, which allows you to do almost anything really. Some of these things can get quite complicated in the end and allow you to do some weird and wonderful stuff. So you can also run it inside GitLab CI. So this is a basic GitLab CI script that runs Debos. And if you click on the link below here, you can see the output of how it looks. But I've also put some screenshots in here. So you can see that the commit that I've made is shown here. How long it only took 10 minutes to build this script. And you can see that it's actually passed, and you can download some artifacts somewhere. Also in GitLab CI, the log is saved every time, so you can kind of see what went wrong and why. We've also added in the ability to run the script on GitHub Actions, which I think is quite nice. GitHub Actions doesn't support kernel virtual machine at the moment, and I don't think it probably will. So we've added in user mode Linux, which I'll come on to in a second. But basically, we can build the image inside GitHub Actions very simply. I think this is 20 or so lines of code that just pulls the Docker container, runs it, and then builds the image. So there are loads more examples. So there's some basic examples in the Debos recipes repository. There's a Raspberry Pi image which runs on ARM64, and I think it pulls the kernel from either Debian, or you can pull the kernel from the Raspberry Pi Foundation's kernel things where they build the kernel nightly. Excuse me. We've also got some Apertus examples where there's lots more scripting, if statements. There's pipelines with hundreds of jobs in. So if you want to learn a bit more about the scripting and the if statements in DevOS, have a look there. So what we've done over the last year is we've actually got the Raspberry Pi example recipe working really nicely. There's a couple of bugs. So for instance, it doesn't work on the compute modules yet, but we're hoping to get that sorted soon. And the biggest thing that we've done is we've added in backend support in Fake Machine. So if you remember, I spoke about Fake Machine before, where Fake Machine actually creates this virtual machine. So before, it had to have KVM support on the PC that you were running it under, which is a problem when you're running in cloud machines like AWS cloud machines, or even if you're running in a system like GitHub Actions where you can't get access to KVM. So user mode Linux just runs as a user process, and it gives you a full Linux environment, ability to add disks and all of that sort of stuff. The only problem with user mode Linux, excuse me, compared to KVM is it's very slow. In our testing, it's about 3 times slower than KVM. But I mean, that doesn't really matter so much when you're running on cheap cloud machines, because you can set your run up overnight. It doesn't matter how long it takes in CI in some cases. We've also worked on a ton of bug fixes. There's been all sorts of problems with KVM or QMU that we've gone through and hopefully sorted out. Again, there are still more bugs. So if you do come across any bugs or things that aren't quite obvious, please do open an issue on GitHub, or you can contact me directly. That's all fine. And then what we're hoping to add in the future is some more useful actions. So for instance, installing Debian packages that you've built locally at the moment is quite difficult. You've got to use, as I say, the run commands where you can run bash commands. We'd also like to add automated testing to DevOS. So every kind of commit to DevOS, we want to make sure doesn't break anything. So we're going to create some basic recipes that just test some very specific parts of DevOS. We're also going to do some full recipe testing where we generate images, and these images should hopefully have everything in that they say they should have. We're adding support for Arch Linux. So this is both running DevOS on Arch Linux and also kind of building Arch Linux images. That's also still ongoing. We want to add more documentation, some example recipes, blog posts, conference talks, that sort of thing. Basically get more people interested in looking at DevOS. At the moment, it's kind of a very internal tool. We'd like more people to be working on it and using it and suggesting things. And we'd also like to start building automated recipes on GitHub. So I mean, this goes back to these example recipes I talked about. So we want to make sure that the example recipes are built, people can download them without ever having to download and install DebOS. So you could download a Raspberry Pi image, for instance. Again, bug fixes, there's always bugs. That's just a problem with software in general, I think. And at the moment, we're currently on version 1 with probably about 200 Git commits on top of that. We'd like to release version 1.1 once things are a little bit more polished. So then now I'll take any questions that appear in the chat. And also, I've been asked to mention that we're hiring. You can click the link here or type it into the chat. We're hiring for all sorts of engineers remotely. We've got a huge backlog of work, so please do get in touch if you feel like working on this sort of thing is something you'd like to do. Other than that, I'll take any questions as and when they arrive. And thank you for listening. My contact information is at the bottom of the screen if you want to get in touch. DebOS is on GitHub as well. It's github.com/go-debos. You can add any issues there, download the code, whatever. So with that, thank you for listening, and hopefully I'll see you again at Live Embedded next year, maybe in person.